My name is Mike Alalade, a customer success architect for Cortex XDR. I've been with Palo Alto Networks for over 2 years, and I'm excited to be with you today. We start at looking at the agent architecture and the different components that make Cortex XDR agents function. The demo instance include both Linux and Windows OS. In part one, we started by looking at some troubleshooting use cases. Today, based on popular demand, we add adaptive policy case. We will round up with some time left to address questions submitted. Either you're running Linux, Windows, macOS, Cortex XDR agents have a very similar structure. And in order to implement agent functionality, the agent includes the following components. The drivers, services, processes, the DLLs. We have persistent database, file system, and the communications component. Of course, on Linux, we'll be talking about daemons, which we're going to go into that shortly. Shortly before we go, we'll talk about the agent components, including services, drivers, and processes. And then when the agent services are running, we expect every admin expect protection on the endpoint. However, we have multiple components that makes XDR. We have the protection components, we have the event collection components, we have communication components, and so on. So when you look at your endpoint, protection is very key. And then we want all the protection components to be active and to be running at all times. Event collection is also another component that we expect to be running at all times. So some of the use cases today for troubleshooting use cases, for troubleshooting case scenario, some of the components may be disabled temporarily or exceptions may be made. But we recommend 100% to have all the protection components running at all time, event collection running at all time. And of course, if you see site runtime stop, we disable the services used by the agent or the XDR agent services to disable only the protection because it's just a sub-component under the agent. You can disable only the protection components alone and then leave the event collection enabled and then the other way around. So we'll go into a demo, and then before we go into a demo, we want to see some of the names that could come across. We have Cortex XDR, we've got Strap, which is the old name, and then we've got Cyvera. For the naming convention, for some of the modules, you can have some of them prefixed with CY, Cyvera, T or TR. Those will probably be the Cortex XDR agents components. So in this case, if you look towards your right, we have site-inject.dll that's being used by Cortex XDR. That's the Cortex XDR injection library. We have Cyvera here, just like we mentioned here. And then we have Cyvera trap.dll. So the first thing is, how do you know if the system is protected, basically? You want to go into, and this is configurable, basically. You could enable the end users to be able to have the console in the tray. And then you can see here, one of the components of the agents, which is the protection components, is enabled. And then we classify them into two categories. Basically, we have the anti-malware protection, and then we have the anti-exploit protection. And of course, this is how you confirm whether they are connected to your tenants, and then the last time they checked in as well. oftentimes you open a support case and then you will have to upload the support file. If you cannot upload that, you cannot generate that from the console, you can also generate that from here as well. And if you have events on the system, you can also see the events from here. The scan, running scans, or if you have active scans there, you can do that and the rest. But if you do not have access to the console, how do you know if the system is running, if the agent is running? So you want to run your command prompts with privilege in privilege mode. I'm running as admin here. And of course, we talked about the use of Site2 last week as one of your troubleshooting tools that you should leverage. We have Site2 runtime query. This enables you to see at runtime the services that are running. So let's start from the lower one here. We have the Tenant, that is the traps early launch anti-malware components. This is normal. It's expected to be stopped. It is loaded when you're booting up the system, and then that launches the site server and validates it to start running. This is the main component of XDR after the system boots up, and that is used, that's all the other drivers are dependent on the site server to launch as well. So another question is, if the system gets rebooted, how do you know whether you're still going to have this protection or not? You can only tell that if nobody has tampered with the startup with the startup settings, right? So in this case, you can see here that when the system is during boots, the alarm will be up, and then this will be automatically loaded because when the agent installs, when you install the agent, site server is installed as a protected Windows service and is used to start, you can see that it's going to start the other drivers as well. So, and of course, another component that we talk about will be the registry. This is where we keep some of the settings that hold some of the settings of the XDR components. So in this case, let's look at Cybera because most of them are C, right? So let's just go to C and then look at some of all of that. So we have the site server here, it's launched as a protected service, and then we have the other components that are dependent on it. You can see the other drivers as well. This is the file system, and then we have the mitigation driver here. Outside that, if you take a look at the processes that are launched using the task manager, you see we've got the main service here. That's the agent running, and then you can see the memory that is being used, and then you can see in here you can see the local analysis components. That's one of the components which we're going to expand on shortly. But you can see multiple instances of that. We spawn a local analysis worker process per logical processor. So in your case, you may see 4, you may see, just based on the number of logical processors you have, and it's done in order to distribute loads between the cores and maximize utilization across those processors that are available. Of course, we have the site tray that's running. That's where we pushed up the console. And then if you go all the way up as well, you should be able to see the console running as well. And apart from that, we have libraries. So when we look at the registry, right, apart from the services settings that you can see here, the policies that are pushed from the tenants, we have some of those configurations and settings and the policies that are kept within the registry. So for example, when you look at the processes that are being protected by default, these are some of the processes that are being protected by default Of course, you can configure to add more, especially when you have custom processes as well from your organization. For example, PowerShell is enabled to be protected by default. So we have PowerShell running now. And then if you take a look using the process explorer. So let's use the process explorer in this case. And then let's look at PowerShell. You will see the three libraries that are loaded by XDR when a process that is protected is being spawned. So you have the injection library, you have the client library, and then you have the exploit prevention client here as well. And of course, some of these settings as well, if you want to see, we have a persistent database that is used to store all the some of the data that's that is being used by XDR. So, for example, we have we in every file that you use, we have a verdict. We have a verdict of the file that's being used. So we catch and then we store the wildfire verdicts for those files in here. When you create when you add an hash to allow list or block list, we expect that to be persistent on your system, so you can see the database of hash override. And of course, you can see database of current time files as well. So that is, where you see the database, that's a persistent database. When you do a reboot, it is persistent as well. Lastly, let's look at the file system. What are the files that are being used by the agents, basically? So when you go to see the core binary files that's being used by the agents, when you go to program files, you can go to Palo Alto Networks, traps, and then you can see all the binaries there and the DLLs that are being used. That's why we always go into these parts before we launch Site 2. Of course, you can add it to your part, and then you can run Site 2 from anywhere. But this is where you see we have the local analysis worker, that we saw within the processes right now. This is the application for the Cyber console process that we saw right now, and then this is where you see all the core binary files. And of course, the agent configuration files will always be here. This is traps, the XML document that stores the configuration of the agent. Now, from time to time, XDR generates data, right? As it's running, we are generating logs. The old name Cyber is there. So this is where you see the log that's been generated by the agent. For example, let's say we have let's immediately open a new window here, and then if we have a malicious file, a test malicious file that we launch, and then we've got an alert here. Immediately, this alert is created, and then the system is connected to the tenants. The copy of this alert information will be sent, but the details of the alert, of course, is going to be kept within the prevention folder. But right now, because the agent prevents unauthorized access to its components, so we cannot open that right now. In cases, if you need to be able to view that, all you need to use is you always go and use your Site 2 command as well. So you can query for all the components in here, and then you can see that the agent process, the agent protect the process registry file services and the pipe. So if you want to access that file, all we just need to do is to do Site 2 protect, and then we can pick, we can choose to just disable the file, right? And then we always need to supply the administration password, and then you can see now that we have the files that's been disabled. So you can go back right now and see the list of data the alert data. Of course, you can retrieve this alert data directly from the UI, but just something for you to know. The files that have been quarantined as well, you can go ahead and see that after you've already disabled the protection on those files. So those are the different stuff. So if you go to the contents are being pushed from the tenant, right? So and then you see the contents in here are being pushed from the tenants, and then the settings and configuration that needs to be stored will be to your registry and then to the persistent database where applicable as well. So that is on the Windows. On the Linux side, basically the structure, like I said, the structure is very similar. The structure is very similar. We need to go into we need to change, need to switch user, and then after we switch user, let's make quickly. Then we can change to the paths where the binaries are, right? And then unfortunately that's not, but we can switch to the paths where the binaries are, and then you can immediately start looking at where all the whether you have protection, for example, what are the running processes here. So we've got the daemon. This is the main agent daemon, and then it spawns the other processes, right? And then we talk about local analysis components in the Windows environment. This is what is responsible for that here. Injection into those processes, we have the DYPD, and then for non-ELF examination, we have the SED. This handles all the communications between the different processes, and at the same time to the Cortex XDR tenants. When a process needs to be terminated, of course, this is the main agent, and then this is what handles that with the kernel. For the different files as well, so you can go into OPT, you can go to traps, and then you will see the binaries, the binaries that we talked about in Windows as well. This is where you see the config files, basically. For you to see the agent XML agent, the configurations for the agents, you can just look at the traps, the XML. So you're gonna see this is where the configuration for the traps is. You can see that the default log level is 6. Of course, you can change that using Site2 as well. You can see the description ID. This is what tells. This is what tells if the tenant that the agent is communicating to. You can always see that under the agent installations from the UI. And of course, for all the different files, because that are being used by XDR, you can go straight again and use and open up command.xml. That is where you see all the files. Like we have the varlog traps. So in here you can see all the log files being created for each of the daemons that we talked about, and then the Cortex XDR log itself. And if you want to check again, it's the Site2 command. It's pretty similar to across the different platforms. If I want to check whether the security component is actually running here, all I need to do as well is just to call for Site2 security query, and then you can see whether the security profiles are enabled or disabled. Alternatively, for the other components as well, we talked about the event collection the other time, the event collection query. This is the data that we use to be able to plot the causality chain. Whether you have an alert on the system, whether a rule gets fired or not, we continuously monitor and collect all of that for you to do threat hunting, and then for other components on the agents to be able to take action as well. So you can see that we have them in most of them in enabled by policy, and then in the running states, they are actually also enabled as well. So we go back to the demo, we go back to our presentation, and then we come back to this shortly. Yeah. So Cortex XDR agent design is modular and it is multi-layered. The protection offered is broken down into smaller sections called modules. it allows us to be able to isolate each of the components, and then it helps in debugging process. Let us imagine we have a legitimate process that encrypts a certain part of the file system, and it makes a ransomware. We do not need to make an exception for that process for all the components. You can specifically target the ransomware protection component and then make exceptions specifically for that process. So generally, we have Cortex XDR post protections broken down into three sub-components. We have the pre-execution, we have the cloud components, and then we have the post-execution components. Pre-execution stage. Evaluation is done before a process is launched from an executable. So we've got the local analysis engine here. We've got the cache threat intelligence that evaluates the files against the files that wants to be launched. We have technique-based exploit protection. And then, of course, we leverage the expanded resources that you have in the cloud by Wildfire to give a verdict before the file is launched. And then after the process is created, we continuously monitor with other components as well. So we have the ransomware protection components, and then we have the behavioral threat protection components, which oftentimes I'm going to refer to that as BTP as well. So from like we saw from the console and from the UI point of view, for configuration purposes, all these components are being grouped into either malware component and then exploit protection component. I start event collection here. I start event collection components here because event collection, as I mentioned before, you use that to plot the causality chain, and we have other components like the analytics engine that consumes that to be able to immediately advise you and generate an alert when there's deviation based on the baseline that has been created. We have other components like BTP as well that leverage, that event collection. So like we said at the beginning, you want all the components enabled. So to demonstrate the multi-layer protection, let's take a look at a sample attack chain with multiple stages before the objection of the malicious actor is achieved. This is the popular emetic wiper that leverages functions in the legitimate software to overwrite the MBR and corrupt the file system. The first stage, the malicious file is dropped. Then to be able to prevent the recovery of the corrupted file system, the malicious actor disables the volume shadow copy to create a blind spot for the drivers and the functions that are going to be used. The actor decides to modify the registry and then extract the drivers to be used. And lastly, the objective here is achieved. It enumerates the files and corrupt partition information. Now let's take a look at how the previously discussed components map to detect and prevent at each stage. When you have a malicious file, the execution-wise, we talked about XDR. We leverage local analysis to be able to evaluate whether that file should run or not. We have general rules that you can use as well. We have the BTP, and of course, we have the cloud component, which called the Wildfire. And for the actions taken afterwards, like disable the shadow copy, we have the BTP that is able to terminate that as well. We have analytics, and then we have BTP as well. So the question is, if we're going to disable one of the components, are we still able to have the visibility needed detection and prevention? Yes. We're still going to, because we are not talking about a scenario where the system becomes completely unprotected. We are talking about a scenario when one of the protection is one of the components of the agent is disabled. So, and how do you know how do you have visibility when one of the components is disabled? You can see that under the all endpoints table, you have to right click on the operational status itself. And then you go to endpoint data, and then you go to view operational status data, and then you'll be able to see the exact component that's been disabled. In this case, just like we've talked about it before, we have the data collection here, we have the malware components, we have the BTP component, we have the exploit protection component, we have the Tenant module. So that is how XDR is able to break down those modular components, and then is able to report on it as well. Last time we started by discussing different troubleshooting use cases. We talked about a case where Cortex XDR impacts a sanctioned application. You want to check that if you miss that out. We talked about agent not registering to the tenant. And then we talked about the agent's communication issues as well. Today, we start by looking at when endpoint status change from protected mode to unprotected or partially protected mode due to adaptive policy. Before we continue, let's take a look at resource utilizations by the agent. Cortex XDR agent resource utilization in terms of memory and CPU varies and is directly related to the endpoint OS. And as well as the number of high resource intensive applications being injected to by XDR. And lastly, by the number of XDR protection components enabled. There will be a difference in resource utilization, for example, between my SQL database versus non-SQL server, or between a standard workstations and a VDI or POS terminal. But in very rare and few instances, an agent could suffer from a technical issues or misconfigurations that interferes with the overall system performance. For example, a spike in site server CPU in Windows or TRAPSD in Linux. So the diagram above shows 3 processes being protected. We have process 1, 2, and 3. The upper diagram shows a scenario where we have unacceptable resource usage, due to a number of components in red. While the lower diagram shows the case, where we want to be, where all the components, some of the components have been disabled or exceptions made. On the far right of the top section, we have vendor B. So we have a third-party endpoint running concurrently with Cortex XDR. In some cases, due to incompatibility, we can have some race condition issues, or there could be, and then could result in resource spike, which you see in red. Also, we could have more events generated, and then we have the need to have more data collected. So that could spike, the agent utilization in terms of data that's been collected as well. Also, we have a process that demands high resource utilizations, and then we get into that process. We could have an unacceptable, resource usage as well. So the best way to tune a system is to target the bottleneck or the modes which limit the overall system performance. And in a very reactive state, you can decide to immediately make an exception for this process. If it is not needed, you can immediately disable the other anti-malware. And then, of course, you are able to optionally disable the data collection component as well. But that is a reactive approach. The new approach now, which you just newly introduced, and then you're going to continue to see a lot of improvement on it, is the adaptive policy. Before we go straight into the adaptive policy, we talk about the order of preference for actions that you can take when you come across some system performance issues on your system. Also, we recommend to always contact support, provide the tech support file, and describe the behavior. What is the baseline before running XDR? What are you seeing? Is it just one-time kind of event, or it is persistent across 1 or 2 systems? Of course, you can create an exception for a specific hash, or to enable a specific process from a specific XDR component. Again, if data collection becomes an issue due to performance, you can reach out to support. They can advise you to either disable event collection or some other action. In some cases, you may just want to restart the service as well. And in cases where you need to pause protection, you can use Site 2 security disable or use the pause protection available from you on the UI. It is on a very rare cases that you want to completely disable the agent. So that's where you use Site 2 runtime stop. And of course, we always recommend that you reach out to support before you uninstall the Cortex XDR agent, and so that we are able to find the root cause and then address that. So what we're used to normally is the reactive way of looking at stuff. For example, if you look at the memory, the processes being used in here, I think let's use the RESTmon component, because this is something that you can leverage a lot when it comes to troubleshooting. We have the site server, the main components in here, and let's say for a reason we just decide to if you look at the CPU that is being used right now by site server let's go all the way up. You can see we have the average CPU 0.03. When it comes to the disk, you see a lot of the event collection activity here, a lot of I/O processes happening here, because we continue to collect the process context for us to use to protect the endpoint, and as well as to plot the causality chain and use that in the cloud for analytics as inputs to the analytics engine as well. So if we go ahead right now, you can see the memory that is being used in here right on my system, right? So if you go ahead and then for some reason you want to react to a spike in the resource utilization, you can go ahead, for example, and say, okay, let's disable one of the components. When you do that, of course, that's a privilege action. Then you need to provide the password. And when you do that, what happens immediately is you will see immediately the resource that is being used by that component, starts dropping, right? We see a drop in the resources, basically. So, and then if you go and query for the different components of events that's been collected, you will see the drop in that. Just a moment. Just a moment here. So, and that is a very reactive approach. If you want to pause the endpoint, you can see that the endpoint is still showing protected, even though the event collection is done, because you just disable one of the components. For some reasons as well, if you do want to pause protection, you can use Site 2 security disable as well, and then you have to provide this password, because this is a privileged action as well. Not anybody can do that, and that should take the protection off the table immediately. You can see the protection is disabled. But the thing is this, the overall services, there's still communication. So if you see it's still connected, because you did not, the agent is still running. So because you did not key the agent completely. So that's something that you just need to be aware of. So for now, we will go ahead and then quickly turn back everything up, because that's not the state we want to be, right? So, and of course, we want to everything to be enabled, so there's no need for password. So that we always go through. Event collection as well, we can immediately enable that. You can immediately enable event collection back to start running as well. Let's go ahead and then enable that. So and that continues as well. So we have all our components enabled right now. Lastly, let's immediately, because of time, let's immediately move to the component. So for proactive approach, right? This has been improved on from version 7.7, and then we have adaptive policy now. Adaptive policy periodically monitors your XDR agent running statistics. For example, the resource usage. And when an issue is found, like iCPU or memory, it disables one or more Cortex XDR modules, just like we just did, but in a very automated and proactive fashion to ensure that your system does not become unusable. The algorithm is detailed, but in very simple terms. Imagine you have a specific protected process crashing 3 times in the past 30 minutes. And the agent sees that, or the CPU used by the agent in the past 30 minutes exceed a certain percentage. You want to immediately move the components around, and that will be done by the agent. So to address the iCPU or memory usage detected, XDR automatically respond first by disabling 2 different sets of exceptions, monitors that. If the issue passes, then it disables a number of components as well. We call that exception that is applied, we call it adaptive policy exception. This is similar to the support exception that you collect, which is a SUES, but this is temporary. And when the component is disabled, right, it retains that status for the default number of days to eliminate frequent changes. So when the first action is taken due to iCPU, you will see the system, the endpoint status going into partially protected mode. There are so many reasons why a system can go to partially protected mode, but this specific use case is when adaptive policy is in action. So you can see that data collection is disabled by adaptive policy, and the module is also disabled by adaptive policy. And also, when it is completely unprotected, you can see that after the issue persists, the second exception is done, and then you can see that all the other components has been disabled. Of course, you can immediately go into your view and see I have a system here that is partially protected. I can go take a look at that and see why that system is in partially protected mode. Just like we saw, it has been disabled by adaptive policy due to a reason or the other. And then we have a case of unprotected situation here. So you can have a look at it, and then all the other components has been disabled after the issue persists. So now, when this changes, what do we expect you to do? You need to have monitoring in place. This is a sample correlation rules, which of course, this is not, was just something done in a hurry, just to make sure that you have a view of what you can do. As the operational status is changing, you can start tracking for new operational status change. And of course, you can have that done in SQL, evaluate that maybe every 30 minutes, and then query for the last 30 minutes, every endpoint that the status has changed to either unprotected or partially unprotected mode. And of course, you can go ahead and then set that as an alert medium and choose the category that you want. And afterwards, specifically, you can configure the notifications to be sent. You can configure the notifications to be sent to you by email. You can configure notifications to be sent to you by email, specifically by using a filter. So you're going to pick the alerts there, and then you're going to pick the description. You're going to pick the description with whatever you have used when you are defining, when you are building your correlation rules, basically. And then you're going to see when the status is changing as well. So an endpoint here has been changed to unprotected, and you can take an action if you choose to do that. Now let's go back to our presentation now. So let's go straight into the demo, and then we'll come back to this because of our time. So for the purpose of this, I have set up an endpoint that is going to that's adaptive policy we evaluate quickly on. Of course, you can always leverage your site to be able to see the status of the adaptive policy. So all you need to just do is to do site to adaptive policy query. So if you do that, you always have to supply your password, and then you can see in here that an action has just been taken. The interval here is this gets evaluated every 90 seconds, right? And when an action has been taken, in this case is the data collection here that has been disabled, right? But the system is going to reevaluate again, like I said, every 90 seconds to see if further actions need to be taken. Let's see if it can create a spike again in the processes. So you can see Cortex XDR is running at 26.5%. So there is every possibility that the next evaluation, based on what I set, because for the purpose of the demo, I've reduced what is acceptable for the CPU. I've tweaked the component, the metrics that's being used. So let's go ahead and launch PowerShell and maybe do some other stuff. So again, that is enough because I raised this stuff very low. So if you continue to look at this, you can see that the agent is still in an enable state. So we can check in, everything is fine. So which means that when you go to site 2 security and then you query, you still have protections on these endpoints, right? Now, after the next evaluation of 90 seconds, you expect things to change. So let's see if we can, okay, we have the task manager there. Let's run other stuff as well, Chrome. Just to make sure that we trigger the AI stuff. Then let's go ahead. Let's go ahead and check again now. Adaptive policy query, XDR 01. Just a moment so that we can observe what happens after that is done. Basically, on a normal system, when you go and check the adaptive policy, with no exceptions applied, by default the evaluation is done every 15 minutes against the data that has been collected every 30 minutes. So let's look at let's query for this system. So when it is empty here, you know that there's no exception. Event collection has not been disabled. No component has been disabled. And then this is near 100 seconds, right? So on a system where you have ICP utilization for some reasons, you're going to expect that. And of course, because we are not able to trigger the other component right now, let's see if we can do that again using another quick way to trigger that. Let's do 60 here, save, and then let's do a recalculation. So we did a recalculation right now, and then you can see now that the protection has been disabled completely. So when you go straight into the query, you will see that the new exception, a new exception has been attached. So we have the agent disabled now reason D to iCPU because we are able to run multiple stuff while we are taking that the acceptable CPU usage among the metrics, among the input is 0.0001. So because of that, this is going to trigger the protections being disabled. Of course, you see the protection component is disabled, but the services are still running. So what do you do if you do not want to, this is unacceptable on a system? You can immediately just go and look at all the other options that are available to you. You have the ability to override, and reset it using the interval. All you just need to decide to adaptive policy interval and then specify the number of seconds if you want to do an override so that it doesn't happen every 900 seconds again. A value of 0 disables the recalculation and remove all the exceptions. That is what you want to do. If you want to do that, then of course, if you want to collect stats, just we trigger a recalculation now so that we can see what happens in here. So let's go ahead and then do interval to be 0. So then we supply the password. And then you will see that when we check again right now, you will see that the exception has been removed. And then this is not going to run again because the interval, is set to 0. So you can also change it. You can also change these again. You can also decide to change that. Sorry, there is an exception that may not allow that to be the change that we made right now to be enforced. So let's make sure that we correct that. So that should be, make sure that we correct that. So let's go ahead and then quickly, this is the system that we're working on. And you can see right now that the operational status data is showing that everything has been disabled. That is the status. And then if we go back, in a few minutes, basically, we should see that after the changes that we did, we should have the system goes back into protected mode. So that is a quick section with the, let's just give it, 3 minutes. We should have the changes here. We should have the changes there. We are on Lab Apex, right? So then, let me check in now. It's not supposed to recalculate. And of course, we're forcing it to interval to 0. So that should return back the system into and remove the exceptions, basically. So let's give it a few seconds and continue again with our presentation. So again, from the, I have one more slide to finish. Basically, everything that I've talked about, this is the command that we use right now, and then I use site to adaptive policy interval. This is the screenshot that we saw when the first exception was applied due to our CPU, and then when the system goes into unprotected mode due to iCPU. And of course, this is how to manage and then remove the adaptive policy from running the running cycle and then removing the existing Apex as well. Also, we've got, like I said, you have to optimize this because it's going to be noisy, because it's going to report the old ones as well. So you need to add the correlation rules and then have that. We talked about the order of preference. Please stick to some of these practices, best practices, and then before you uninstall the agent, it's good when you have one component turn off and then 9 components are enabled. You still have protection on the endpoint as well. So lastly, when you open a support case, there are different set of data that may be required by support file. You can generate this from the Action Center. You can just go to all endpoints table and do this and generate this. The alert data, you can retrieve the alert data on the alerts. You can take a screenshot of your task manager. You can use Document to capture the process logs as well. And then just like we use Resource Monitor to see the disk activity and then the other activity, CPU and memory as well, you can use Resource Monitor. For debugging purposes, again, you may be required to change the log level using the site tool to 7 or so that you can get change the verbosity level. Then later you can change it back to the default so that you don't generate too many logs in your environment. So and at that we go into the other stuff, just how you generate the technical support file, use the proc num, and of course, lastly, the questions. We'll look at the remaining questions right now. All right. Okay, so we've got the XDR AirPower. That is, again, it is a proactive approach for us to be able to monitor the health of the agent. So that's where we have the XDR AirPower on the system. This is, like I said, during the adaptive policy presentation, the algorithm behind it is complex, and as well, and because of that, there is no it's taking a lot of inputs. Some of them, one of them includes the CPU resources that's being used by the agent. So the algorithm is more complex, so it takes a lot of inputs as regards the running statistics. So I'm not able to really pinpoint directly. Only engineering can actually tell what the metrics that's being used are. So again, automatically, when you install XDR agent on workstations, by default, XDR agent becomes the, so when you go to Windows Security, you will see XDR as the, when you go to Windows Security, you will see XDR as the endpoint protection. For the agents, for the servers, you have to use, you have to force Defender back to passive mode. So that is the question about Windows Defender services, basically. And for exception, really, so there's so many ways by which you can make exceptions. You can add a particular hash to allow list or to block list. We have a webinar that details how you can make exceptions based on file and different processes. So you may want to check that out. So for when you have an agent, in a partially protected mode, there are different reasons why an agent could be in partially protected mode, like we talked about the other time. So in some cases, if you encounter that, for example, if you encounter an incompatibility, this is a Linux instance. If you encounter partially protected for, you can check if your system, your operation mode of that Linux, and it is incompatibility, you can change it to what we call the user mode. All you just need to do is you go to your agent settings, change the configuration to user space for that specific group of endpoints. Make sure that the kernel version is a minimum of 5. If it is not a minimum of 5, then user space mode is not supported. So that is about the question about user mode and the kernel mode operation. So right now, the same way that you have the agents, the same way that you have the grouping of the agents the same way that you have the grouping of the agents for policies. Right now, within the alert table and the incident table, you can make use of the tag. So check out the tag there. The tag allows you to be able to look at the number of the incidents based on group of endpoints, as well as the tags that you've defined as well. So I think I may have to stop there because of time, and then we will respond to the remaining, and then we'll share that with you.